right, let's do the key to your warm up for so that you are prepared for your quiz to the first part of the normal model unit. All right, so we're finding the percentages. Now, in this first section, you will see that you were given the x values, so you needed to turn these into z-scores so that then you can compute the area. So x minus the mean over the standard deviation. You'll also notice that I did not provide you with the guideline of what you write over here, that the mean is 30 and the standard deviation is 4 and your x value was 40. So I kind of left you to your own devices. You may have written that yourself. All right, so then we get the area. Oh, look, I went so I think that I went the wrong way for this. I can tell already. Look, because it asks for less than, and I went from 2.55 up to 99. That's not less than. So I did mine wrong. And so I need to recompute and go from negative 99. So my lower bound is going to be negative 99. And then my upper bound is going to be that 2.5. And then we'll get our area from that. Okay, so here we have it. 0.993. Now look, before I write that fourth decimal down, I will look behind it. So 0.9938 is what that is, not what I have written there. So I'll have to fix that. I had seen an error on another earlier problem too. So 0.9938 equals 99.38%. So we'll see what else, if I have any other areas coming about. All right, so there's the answer for that. Next, we want to find, now this one is a greater than. Okay, so we're going to go ahead and find the z-score. X minus the mean over the standard deviation is negative 2.25 and greater than. So we want to go from that negative 2.25 up to 99. And so that's 98.97%. Here it is in between. So we needed to do two z-scores. Now, you may or may not have had to write this one out because if you are a person that has some common sense, then you would know and recognize that 30 is the mean. So you know that that automatically has a z-score of 0. All right, but then we do for 35 the z-score and we get 1.25. So our area from 0 to 1.25. Notice how I do this notation. Z is in the middle, 0 on the left, 1.25 on the right, 39.44%. All right, then we get into all word problems. So let's see what's happening here. So this is about the speeds of the vehicles, of the cars. And so they have an average of 90 kilometers per hour with a standard deviation of 10. So we were talking about traveling more than 100 kilometers per hour. So when we get that z-score of 1, we're going to norm CDF from 1 to 99, 15.87%. And again, you can write your answer either one of these ways. You may choose to write it the z-score is greater than 1 or probability that the x value is greater than 100. Either way is fine. Next, this is about our computers and the length of time between the charges of the batteries. We know that has a mean of 50 and a standard deviation of 15, and we're going between two amounts of hours. And so that means we had two x values. So you have to solve for two z-scores. One of them is the mean. So that's a z-score of 0. One of them is 70. So that's a z-score of 1.33. So we're going to norm CDF between 0 and 1.33 to get our area. Notice how this notation is 4 decimals and then a percent. Okay, here we go. Oh, this one, now we want to know how many items. So this is a two-step problem. where you not only determine the percent of items, but then you multiply by how many there are to find out how many items fall in that category. So we are talking about the lengths of these components and the mean of 5 centimeters, standard deviation of 0.02. We're going 4.97. So there's our x minus the mean over the standard deviation. So we were wondering about being shorter than that 4.97 centimeters. So I get the area below that location. So I norm CDF from negative 99 to negative 1.5. And that just gives me 6.68% of components. So if this is too short, then you're going to have 6.68% of the components not meeting specifications, okay? Well, but I don't want to know what percent. I need to know how many items are going to be defective. Well, of the 200, I'm going to take that decimal, 0.0668, multiply it by 200, and then I get 13.36, which I will round to 13 components. So about 13 of them are going to be shorter than 4.97 centimeters. All right. So maybe this is the ideal size between 4.98 and 5.05 centimeters. So that's two x values. So we'll find the z-score for both of those. And that's first z-score is -1, second z-score is 2.5. So norm CDF between -1 and 2.5 is 83.51% of the components. So if this is the ideal size range for them to be, then 83.51% of the components are in that category. But how many of the 200 components? So that decimal times 200 means they'll get about 167 components of that size. All right, and now we're talking about the length of the life of an instrument produced by that particular machine. They have a mean of 12 years with a standard deviation of 2. So find the probability that the instrument produced by this machine will last less than 8 years. So what's the probability it's going to be you're going to get screwed over and you're going to get less than 8 years usage out of that instrument. So mean of 12, standard deviation of 2, the x is 8. So we get our z-score and we're going to norm CDF below that. So just about 2.28% of instruments would last less than 8 years. Check out your notation there. How about between 13 and 15 years? Then you're doing good. You're getting longer lifespan out of those. So you have to find two z-scores. You have a z-score for 13, and that's 0.5. You have a z-score for 15, and that's 1.5. So look at this notation, the probability. Your z is in the middle from 0.5 to 1.5. Your inequalities point to the left. So that is 0.0228. So only about 2.28% of your instruments are going to have that extended life. Now, here's one last type of problem that you need to be able to understand what's happening here. We want to know which instrument or which situation would you consider more unusual? Would an instrument that lasts 15.5 years or an instrument that lasts 7.5 years? Well, give statistical evidence. Don't just ramble off your thoughts about it. No, you use the information above about the mean of 12 and the standard deviation of 2. And so then when you do that, you find the z-score. So an instrument that lasts 15.5 years is 1.75 standard deviations above the mean. But if you have an instrument that lasts 7.5 years, it was 2.25 below the mean. So it was more unusual than the instrument that lasts 15.5 years because even though it is in the negative direction, it is more standard deviations, it is farther away from what was expected to happen than this instrument that lasted 15.5 years. All right. And so that is the end of your warm up. And I hope that you then do well on your quiz. Good luck.